reason they couldn't. So, my name's Josh Varty. I work for a company called Code Connect. Me and my friend over there, we co-founded it just not too long ago. We develop Visual Studio tools, which means we spend a lot of time digging around Visual Studio DLLs. It's one of the less well-documented areas of Microsoft's tooling, and it means you spend a lot of time decompiling other people's code and trying to figure out what they did so you can try and make your tools do similar things or achieve some goal. So DLLs at their core are nothing more than data and functionality. We use them as libraries when we compile our C# code to IL. Other people can depend on them as libraries. And I suppose the same could be said for EXEs on the Windows platform as well. These DLLs that we use, depending on who they come from, can occasionally be buggy, and we'll be walking through some bugs that existed in the Roslyn compiler tools, at least in Visual Studio 2013. And another problem with Visual Studio, or with DLLs in general, is sometimes they hide the good stuff. So when you're working with these DLLs, you might be surprised to learn that that really awesome method that you wanted is marked as internal, which means you can't get access to it, which is a huge pain in the butt when you know it would do is make your day a lot easier if it could just be public, and if only these people would make it public for you. And that sentiment was echoed on Twitter recently by David Fowler, complaining that that's the case with a lot of these things. So, at its core, C# compiles to IL. We're mostly all familiar with that. The new Roslyn compiler changes nothing in this equation. But what some people don't know is that you can very easily go from IL back to that C# source code. And you can do that through a number of tools, such as Telrix, Just Decompile, or my personal favorite, Redgate's Reflector. And this tool is really fantastic, and we'll take a minute to just look at it really quickly, because it makes any DLL you depend upon, you can easily browse, inspect the source, see what's going on, see how they're implementing functionality within them. And it's important to be aware of this, even as a developer, that the DLLs that you put out into the world can just as easily be decompiled. So these DLLs right here, these are the Roslyn compiler, the new Roslyn project. And with a single click, we can just explore these with just paint and all. It's not hard at all to get in here and start poking around methods, see how individual methods are processed, and it goes even a step beyond that, because you can just very easily decompile the whole project, export it as a CS project, open it up in Visual Studio, play with it, run it yourself, even change it. But what we're focusing on today isn't necessarily going to be the decompiling and modifying. We'll talk about another way to modify these DLLs through what would be called a rewriter. So instead of decompiling back to C#, which in some cases can be buggy, certain things don't necessarily compile back exactly as you want them to. We can sometimes rewrite intermediate language. We can rewrite these DLLs with almost the same amount of ease and make them do what we want. So we can get that internal method, mark it as public, or we can take a piece of protected software and make it such that things we validated its key when we have it. And what we'll do to explore this is look at a tool called GrayFox. The guy who invented this, his name was John McCoy. He's a great programmer. He's not so good at visuals, as you'll see. He's definitely stronger on the low-level programming side of things. But much like Reflector, which we just looked at, you can very easily import files from here. Let me just go back to that place we were looking at. And at first glance, it almost feels like a decompiler. We can look at the namespaces and the code that exists within here, the same way as we can a decompiler, but this tool is actually a lot more powerful than that. So, for example, you've got your intermediate language here on the left, and on the right you've got the decompiled C#. But what makes this really powerful is that it's really easy to edit. the code here. So personally, I don't know intermediate language well enough to do things like this, but you can take individual instructions, you can rewrite them, you can change them from branch of true to branch of false. Do all the things you could imagine with intermediate language. John actually made this tool even he went a step further, and he said, not everyone's going to know IL, but maybe we can make it such that there's just flags to click. So if you have, if you've got like an internal static member here, it's very easy just to click public. Now it's private. Public, private, get rid of that. So now we've got this DLL here. It's marked public. We've exposed the functionality that we were interested in getting at, and we can very easily consume this. So with less than 2 minutes of work, I can go here, save the binary. I could save it over top of the existing binary and consume it as I might want to, or I can save it as a separate binary and use it separately. So what we'll do here is we'll look at a real example. We'll close this guy here. And we'll open, actually we'll run it first. We'll take a look at a very simple app that I made just before this presentation. And all this app does is it takes what's supposed to be a password of some kind, validate it, tell you whether or not you input the correct password, and if so, display the correct password to you. So say if I didn't know what the password was, I could take an app like this. I'll just copy the path here. And I could very easily load it right up in Grey Wolf. And we can start poking around at the internals. So we've got two classes here, enter password and program, and we can start looking at this enter password class, and we can see that there's a button click event that's checking whether or not a password is valid. So we might want to know what this is valid method does. So we can poke down there. We can see, oh, it's cached. It's calculating an MD5 hash of the password. Then it's comparing it to this existing hash password here, which we could poke around it and look at. But even before we have to do something like that, we can start looking at the IL. And I don't know IL very well, but I know branch if false, and branch if true, and some of the absolute basics. And with no problem at all, we can just go in here. We can change this condition to branch if true. It looks like it'll load a 0 into this register here. So if false, it's going to load 0 and return 0, which means it's going to return false. So if we change the condition here, it's going to fall through to this branching condition and return true. So all we have to do is just go down here, change the opcode. He's got the whole list of the opcodes. I don't know too much about these, but they're all there for you. And they've got sort of an explanation of what they do. And now we can just export this. So we can save this binary. I'm going to save it somewhere else. I'm going to save it as edit. So now with this new binary, we can just load that up, and if I did everything correctly, I can just put in whatever I want garbage, and it comes back as valid password. So you can imagine how people who crack, Reflector or paid apps would use a tool like this to get in there. And these are sort of the kinds of powers that can be used for bad and they can be used for good. This is obviously something you probably wouldn't want to do. I'm suspecting it's illegal in most places. We're from Canada, but I imagine the laws aren't too different down here. So I wouldn't recommend doing anything like that. But where we found it useful was when we were working on an application that was deeply integrated with Visual Studio, that we got to the point where we found Visual Studio had a bug in it, or the new Roslyn compiler had a bug in it. And this would have blocked our release by months. We would have had to wait 5 months before we could have released our product out to people for testing. So what we did was we used similar methods to this, to go in and fix this bug. So I'll start by showing you the project we're working on and the bug that, that we faced. So here in Visual Studio, we built an extension, and the idea behind this extension is instead of treating files as the smallest unit of code, we wanted to break them down into functions. So we'll launch our application here, and what you'll see right away is you've got one function, then you've got all the functions that it calls to its right, and if you navigate there, all the functions it calls, and this is integrated right within Visual Studio. You can see exactly how the functions correspond based on color. And we built this extension using the new rosin APIs. This wouldn't have been possible without the new rosin APIs that we provided. And what you'll see here is, as I type here, my changes are instantly mapped back to this, source buffer right in Visual Studio. And the bug that we faced was the special buffer that our editors live within is called an elision buffer. And basically what that means is it's taking its source code from one place and it's mapping it into a custom editor for us. And I'll show you just back here, we have this elision buffer class, and this is the class hierarchy that existed within Visual Studio. You've got this elision buffer. It inherits from iProjection buffer base. Then on the other side, you've got another sibling class called iProjection buffer. Now the difference between iLesion buffer and iProjection buffer is iProjection buffer can take text from two different, more than two, as many as you need, different source buffers, and project it into one single buffer. So when you're using like Razor web views and you've got HTML interspersed with C#, that's using an iProjection buffer. But the tool we built was using this iLesion buffer. And when we ran our tool, which I'll do here for a second, in Visual Studio 2013, so this is 2013 now, not 2015, what would happen is we would get a really frustrating crash where there was some null reference error deep within the bowels of Visual Studio. So we spent a lot of time tracking that down, figuring out exactly what line of code broke it. And while this loads, I'll just show you guys. So, whoops. While this loads, we'll just fire up this slide again. And basically what's happening here is there's a method that's trying to work with these buffers. And all you need to know is that we have this start buffer, which comes in as an iLesion buffer. This is the buffer that we use. Visual Studio was mistakenly casting it to an iProjection buffer when it should have been doing iProjection buffer base. So what's probably happened here was someone was using IntelliSense. They clicked complete and it completed to base, and they didn't rip apart the editors the same way we did to uncover this bug, because not very many people do that. So it went unnoticed for some time. So we ran into this issue, and this one line of code, this mistaken cast, would have cost us a lot of time. So what we did was we used a tool we used the tool that Gray Wolf uses under the hood, mono.cecil, to rewrite this line of code, just one line of code. And before we continue, it's worth asking ourselves, is this something we should realistically be doing? What kind of problems can arise from, changing Visual Studio DLLs? And it turns out a lot of bad problems can happen. When you do that, all of a sudden C# doesn't load. So you go to the Solution Explorer, and there's an error from MEF just displayed in plain text in your Solution Explorer. And then you click on the exit button, and you find out it's routed with MEF as well, so it can't exit Visual Studio. And a lot of just awful problems happen. Internally within the Microsoft team, they have this concept of MEF wizarding levels. So MEF is, if you don't know, the Managed Extensibility Framework, and it's the way we can extend Visual Studio. We export things and Visual Studio consumes them. But debugging MEF problems will earn you the title of MEF Wizard 1 or MEF Level 2 or Level 3 within Visual Studio.
The new Visual Studio that has actual error messages now with details.
Yeah, thanks for that. Well,
It only
been
took
useful
30
5 months ago.
It only took the third completely read from scratch.
Yeah, exactly. So we had these problems, and I'm sure the Microsoft people would tell you not to do this. So if you revisited this question, they'd say, no, don't do that, never do that. But with that being said, I'd like to tell them I'm altering the DLL. You can just pray that I do not alter it any further. So we needed to work around this. And what we did was we used this, as I mentioned earlier, we used this mono.cecil project. So if I fire that up here and bring it over. Actually, let me show you the bug that arose before all of this. So if we just open up a test solution and fire up Code Connect within this guy, what we'll find is that most things work well until you do things that rely on the C# language service, such as trigger and telesense. So, this guy over. So for the most part, it's there. You can navigate between these things, but the moment you do Control J or Control Space, everything freezes for a second. Visual Studio lives on my other monitor, but it loads over here, and it says that there's some invalid operation within mscorelib.dll. There's no detail to be found. There's nothing in there of use. So what you end up doing is you use Reflector, as I mentioned earlier. You decompile these DLLs. Reflector's got a great add-in for Visual Studio where it lets you step into the decompiled DLLs, which is absolutely fantastic when you're trying to debug a problem like this, because you can go line by line and see exactly what's going on inside of Microsoft's closed source DLLs, which is fantastic, because otherwise we wouldn't have been able to solve this. So, if we exit out of this guy and close that, what we'll find is that we have this IL rewriter hack project. And this IL rewriter hack depends on mono.cecil, which is this offshoot of the mono project written by J.P. Everett. He created this syntax tree project which let you run Unity Visual Studio. He got purchased by, his company got bought out not too long ago by Microsoft. So we use this tool. There's not too much going on here except for this project here. It's hard for me to see. But basically what goes on, everything here, is we check whether or not the DLL is valid. We have this method called fix Visual Studio, which is where most of the interesting rewriting goes on. And we start a third-party process. This was another frustrating thing. It's very hard to alter Visual Studio when you're running Visual Studio because the DLLs are all locked because they're being consumed. So what we would have to do is launch a process that would wait for all the Visual Studios to close. When that happened, rewrite them under Visual Studio's nodes, and then after that, it would finally work. So if we go to try to repair DLL, then what we find is we have this assembly definition, which gets the broken assembly, which is just a mono representation of Microsoft.codeanalysis.editor.dll. And what we do then is we look for a method that has the name classify buffer map direction. So this was that method that I showed you earlier that was broken. We get the IL for this using this IL processor. And we keep a list of incorrect instructions. And what we consider incorrect instructions were anything that were called iProjection buffer when it should be iProjection buffer based. And we go through and we build up this list. And finally, if there are any incorrect instructions, we build this thing called new instruction, which has a type reference to iProjection buffer base. And it essentially just swaps out those lines, which fixes the bug. And I'll put a breakpoint here and run this. for it to break in front of all of you. I had to short circuit a little thing to say that it was valid, and now we'll run that again. And what you'll see is this code will execute. It's going to ask us to close all our Visual Studios down, and then under our nose it will, actually we won't even be able to put a breakpoint there. My breakpoint won't get hit because we have to close Visual Studio before that code can be run. So I'll show it to you. And then we'll talk about like why is this possible? How am I able to rewrite signed DLLs that were signed with the Microsoft key and not have anything in the CLR or anything get angry at me? And that was sort of the first question we had. We were kind of shocked when it all worked, but with a little digging, we figured out why that was the case. So we'll fire up the test solution, get our start in place again, and we'll go connect. And this time, from my other monitor, we got this thing. And unfortunately, there's a bug within the current version of compiler that must be patched. Please close all instances. So not only do I have to close this instance, but I have to close the background instance, which doesn't like to be closed. And I believe it says there's one left. I have Visual Studio 15. I didn't remove that one, so we'll close that as well. I'm not going to sign in. Hey, listen. All right. And then finally, it repairs the bug within, successfully repairs, and it closes itself. And I'm not going to bore you by showing you how it does work, because you've already seen how Code Connect works. What I will do is talk about why can we do this? Because isn't the whole point of signing my DLL in the first place to ensure that things like this don't happen, that bytes aren't manipulated under my nose? Well, it turns out that was the case until .NET 3.5, at which point it turned out if you have to take every byte of a DLL and hash it and check it against the key, when you're developing like a 2 gigabyte game, that's going to add 20 seconds of loading time to your game. And that is not something Microsoft wanted to have. So what they did was they disabled all of this strong name checking. It doesn't happen even with their own DLLs, except for when you first load a DLL into the global assembly cache, so when you register something there, which doesn't make sense to me because the moment it's there, then I can just edit it under their nose anyway, so I'm not sure why they're checking it at all. But that's sort of the quick and dirty of why this is possible. At the end of the day, Microsoft just decided performance outweighed the security risks of this. I think they're in the right, but at the same time, I can see some problems with this because if I can rewrite DLLs, then I can rewrite the string class, and I can make the string class maybe talk to an IRC server, and maybe when that IRC server sends messages to now my computer, I'm part of a botnet. And you saw I did this just with a Visual Studio extension, no administrator privileges, but you can infect any kind of DLL. And then on top of that, I haven't investigated this, but I'm wondering, if I put something in the string class and I wait for, and I check the permissions that I'm running at and wait for administrator privileges, then maybe I just wait until string is used under the administrator privilege and then I, do something even more malicious. I root the box or something like that. So there are some trade-offs to be made here. I still think the performance can't be sacrificed. Maybe Microsoft has better ways to solve this problem, or maybe just no one knew about it, and now we'll all get viruses. But at the very least, I encourage you to sort of think about these things when you write your DLLs or write your programs. Understand that they can be decompiled, they can be edited. You can obfuscate them, but that's sort of a losing fight in itself. There's always an ongoing battle. But just understand that these DLLs, which you've come to understand as trustworthy and read-only, that's not really the case. And you can do whatever you want with code that's on your box. So, thank you very much. You can reach me at Twitter at thisisjoshvarty, or my website where I blog about Roslyn mostly. And if you were interested in the Code Connect product,